Dudes, dudettes, hamsters, coyotes, whoever else is watching this Station Plots Essentials video, welcome to the video here. I want to talk about the essential key features of a surface station plot and how this is critical and how this is going to help you greatly in your weather forecasting journeys here. So this, I've got a page pulled up here called the Storm Prediction Center at spc.no.gov. So you can kind of do this with me if you want. Go to spc.no.gov. What we're going to do is going to click on the meso analysis right here. And then we're going to click on a region. Doesn't really matter. We'll click on the northern U.S. And this shows all sorts of like current conditions and stuff. But today we're going to talk about station plots. So to find these, this is kind of where you go. And then you go up to observations right here. And then you go down to surface observations. And so there we go. These are station plots. See these right here? All these little things, little dots with sticks on them and stuff. Those are station plots. And they each measure observed weather at a station. Okay, like observed weather in maybe, I think that's York, Nebraska right there. So in York, Nebraska, they collect the wind, the temperature, the dew point, and the sky conditions, and the pressure. So that's let's see, that's 1, 2, 3, 4, 5. Yeah, 5 different variables on these station plots from the SPC, and most will have 5 different variables. Sometimes you'll see like things like that. I'm not going to go into that on this in this episode, but I'll attach a little cheat sheet so that you can figure out what that is. Those are like special weather conditions and stuff. But that's just basically the general stuff that station plots collect. And this is critical in weather forecasting because you can identify fronts, you can identify moist axes, you can see where dry air is at, where precipit's falling, where it's cloudy, like out here it's cloudy and out here it's not. And so it's very important with that, and I use them quite a bit. I think you're going to use them all the time when you're examining weather. So let's crack into the tutorial section here, and I'll go over all of the different little gizmos that each of these station plots has. So let's crack into it. So the easiest way to start off here is to identify a station plot location. So let's do an example here. We're going to do Pierre, South Dakota, and let me check that out real fast. Okay. Each of these station plots has a 3-letter code for the city. So Pierre, South Dakota's station plot code is PIR. Okay, that stands for Pierre, just kind of an abbreviation. And that goes below this circle I'm about to draw. The circle, that's step number 2. That indicates the sky conditions, or the cloud cover. Okay, so how much clouds there are. Okay, and so let's go over that first. An empty circle like this is going to indicate 100% clear skies. Imagine this kind of like a pizza. How much of the platter is filled with pizza? Same thing with sky. How much of the platter is filled with clouds? Here, the platter is empty. There's nothing filled in. Okay, how about this one right here? It's filled in half the amount. That means the sky is about 50% cloudy. It's about half cloudy. Partly cloudy is what the conditions would be showing for that. Okay, let's draw another one. Let's say it's a quarter filled. That means it's probably quarter filled clouds, probably mostly sunny or clear if it's nighttime. Something like this, where it's 3/4 filled, hey, that would be mostly cloudy. Okay, so most of the sky is filled with clouds. And then, of course, something like this, where it's all filled in, would be cloudy. Okay, just imagine that all filled in. So that would be cloudy skies. So let's say Pierre, South Dakota, it's mostly clear out there, so we'll just have a few clouds lingering around. So it looks something kind of like that. So that's step number 1 out of 5. So we got our sky conditions met. The next one is temperature. Let's say the temperature in Pierre, South Dakota is 55 degrees. Where would that go? Whoops. The temperature is going to go in the upper left-hand region of the station plot, okay? The upper left-hand region of this like circle area, so kind of in this area. So it's 55 degrees. Now you don't have to write the degrees. It's kind of up to you. But this is going to be in Fahrenheit. So let's say it's 55 degrees, okay? So that measures temperature. Now, the other thing, number 3, that these station plots measure is moisture. And so it measures dew points, okay? And dew points are essentially the degree that you would have to cool the actual temperature to make condensation occur. And I have videos about this probably on the site somewhere. But to keep it simple, it kind of measures the moisture in the atmosphere. So let's say the dew point in Pierre is 43 degrees Fahrenheit. So you would put that right under the 55 in the lower left-hand corner of this circle. So that's where the dew points would occur. The temperature up here and the dew point below. Remember, the temperature always goes above the dew point, okay? And sometimes you'll hear it like 55 over 43 is the temperature dew point spread. Just make sure it's always over the dew points. Now, to examine our fourth variable, what we're going to take a look at is wind. Our station plots gather wind information. And so imagine you have your little station plot here, okay? To figure out the wind, we make these little sticks that come out of the station plots. Okay, and sometimes they have like little sticks on them, or sometimes they're flags, and I'm going to go over that here in a second. So when we have a station plot without a stick, that essentially means we have calm winds. Okay, the winds are calm. Now, something with calm winds, you're just going to draw a circle around it like that. That means the winds are calm. When we have a station plot that just has a stick, nothing else, nothing attached to it, that means the winds are less than 5 miles per hour, 5 knots, whatever measurement they're using. Okay, it's less than 5 miles per hour. That's what that stick stands for. Now, when we have something attached to the stick, kind of like this, that's where we can start adding on miles per hour. So let's do it. The longer sticks, those represent wind increments of 10 miles per hour. Okay? And then the shorter sticks represent increments of 5 miles per hour. And then these things called flags, they look like that. When you see those attached, those represent increments of 50 miles per hour. So let's say we got something that's 10 miles per hour. You would draw a stick, and then you would add that long stick on it. So that would be 10 miles per hour. Okay. How about 5 miles per hour? You draw the stick, and then draw a little tiny dash like that, because these are smaller, the 5 mile per hour increments. And you draw it in a little bit. You kind of just make a little indentation like that. Let's do an example. How about 15 miles per hour? This is going to use both of them. So you draw your 10 miles per hour stick, okay, and then you add 5, because 10 plus 5 equals 15. So you draw your little 5 dash. Here's 10 miles per hour here. Here's 5 miles per hour there. Those together equal 15 miles per hour. Okay, let's try another one. 35 miles per hour. We'll go over here. We'll draw our stick. So we break it down. 30 has 3 tens. Okay, 10 times 3 is 30. So we'll draw 3 long sticks, the 10 mile per hour sticks, like that. Draw this a little longer. But it's 35 miles per hour. Okay, so we got 10 right here, 10 right here, 10 right here. So that equals 30. We're still missing a 5. So we draw our little 5 dash right there. Okay, that's about half the length. We draw our 5 dash. And that equals 35 miles per hour. How about 55 miles per hour? No, let's do 65 miles per hour. We're going to do one that's 65 miles per hour. We're going to draw our stick. Well, we don't have to draw 6 of those dashes. Imagine it kind of like tallies, where once you have 5, you can draw little slash through it. Once we have 5 long sticks, 5 10-mile-per-hour sticks, we can do this little flag right here. We can put this little flag on. These flags stand for 50-mile-per-hour increments. So since we have 65, we can just slap on a 50 because that's less than 65. So boom, that's 50 right there. But it's 65, so we're still missing 15. So we got to add a 10 right there. So that 10 plus 50, that's 60. And we're still missing 5. So we'll add a little 5 dash right there. That's a little barb that stands for 65 miles per hour. Okay. So let's go back to our station plot. In Pierre, South Dakota, our winds are out of the northwest at 45 miles per hour. But what's that? We haven't gone over direction yet. So the simplest way to see direction is see our flag right here, or maybe here's another example, just our little stick that's coming out like that. This would represent something that's out of the southeast. So we'll draw our compass right here, south, north, east, and west. Imagine that the little stick is coming out and it's pointing to the direction the winds are coming from. I know that's a little confusing, but it's pointing out towards where the direction of the wind is coming from. So this is actually representing southeast winds. So winds that are coming out from the southeast like that. Like you would think it would look something like that. They're coming from the southeast going northwest. But that's not how these barbs work. They point out in the opposite direction to the southeast. So this would represent winds coming from the southeast at 10 miles per hour. This one would represent winds coming from the southeast at 50 miles per hour because that's our little flag. So imagine the flag or the stick pointing to the winds or to the direction the winds are coming from. Okay. Now let's go back to our example, our Pierre, South Dakota example. I think we said the winds, actually let's say the winds are coming out of the northeast at, let's throw a little curveball here, 17 miles per hour. So we would draw it towards the wind direction because the wind direction's from the northeast. So we're going to draw a stick towards the northeast. Whoops, get the paint tool here. We'll draw a stick towards the northeast because that's where the northeast direction is. Okay, so the winds are coming out from this way. And it's 17 miles per hour. So we know we have to add a 10 tick. Okay. And another rule of thumb is these little things, these little wind barbs, sometimes hard to remember, but they point out in a counterclockwise direction. Okay, so it's going to point this way. So imagine things are clockwise, or excuse me, that's a clockwise direction. So they point in a clockwise direction, okay, around the surface. Okay, so we got 17 miles per hour. So we're going to add a 10 dash, that's our 10. Then we're going to add a 5 right there, 15. Now, here's where the tricky part is. That's 15 miles per hour. Where's the other 2? Well, in that case, we just round. 17 is actually closer to 15 than it is 20. If we chose 19 miles per hour, we would round to 20. So we would make 2 long dashes like that, okay? So that's how that works. So we're just going to go with 15 miles per hour out of the northeast. So those are those 4 different features. Now we're going to advance to our last feature, and that is pressure. Now with pressure, surface pressure, we measure in millibars typically. And usually they're going to exist in the upper 900s to lower 1000s. So you could have like a 999.5 millibar low pressure, or just pressure, okay? Sometimes you can get a 1040.6 millibar pressure, okay? It kind of varies, right? The important thing is when we plot these on our station plots, for the 1000s, take out the 10. For the 900s, take out the 9. So really the rule of thumb is you're left with 2 whole numbers here, like that, and then your decimal numbers, okay? So we take those out, okay? Then we're left with 406, okay? Take out that decimal as well. So in this one, we're left with 406. With this one, we're left with 995. Okay, if you take out the decimal, the first number, and this one you take out 2 numbers and then the decimal. So you're just left with 3 numbers. That's all you really want to look for. Just, don't overcomplicate it. You just need to be left with 3 numbers, okay? So that's our pressures. Where do we plot our pressures? Well, let's do an example real fast. We'll say in Pierre, South Dakota, the pressure is 1,020.5 millibars. Okay, so we'll write it out, 1,020.5 millibars. Okay, we'll leave out the MB. We don't need that. So remember, we want 3 numbers. So we take off the 10, and we don't want a decimal. So we take off the decimal, and then we're left with 205. Okay? Isn't that nice? 205. So where does that go on our station plot? Well, it just goes due right of our little circle here. Okay, so it goes right here, 205. That's our pressure. Now, some station plots are going to have a couple of extra features, such as how much did the pressure change? Sometimes you'll see this, sometimes you won't. Like maybe the pressure fell 9 millibars. Okay, so maybe it went from 1,020 to 0.5 to 1,011.5. It went down 9 millibars. So you would put a -9 right there. That stands for the pressure fall, okay, or pressure rise if it went up. So if it went up, you'd do a +9, or you would just leave it as a 9. You wouldn't have the plus. But in this case, it fell, so you would put in -9. And so the 205 would actually end up in the upper right-hand corner, and the -9 would end up in the lower left-hand corner. If you don't have that, just kind of put it in the middle or something. It looks nice like that. So with our pressure little thing I did there, we went over the formal method. You also can try this method out. Let's say we have a pressure reading of 1,018.7 millibars. You can round it to like 1,019 and just call it a day and put it on the map. Sometimes, like some websites will do that. Like maybe we have another one, 987.6. You can round that to 988 and just say, hey, that's good enough for me, dude. And so you can put that on the map. So that's another way, but I taught you the formal way, to get like precise measurements. So either way, that's just some tools in your toolbox. So let's get back to the tutorial here. Suppose that WX Bob, okay, Weather Bob over here, his backyard weather station, his secret little weather station, it has a few different readings that it brought in. So let's say that in Bob's backyard it is cloudy, okay, completely cloudy. Its temperature is 59 degrees Fahrenheit. Its dew point is 36. And let's say the wind is out of the north, out of the due north at 60 miles per hour, okay? There is some serious gusts, big old cold front going through Bob's backyard, and he is out there. He's having a good old time, probably flying a kite or something. Oh, but wait a minute. There's a thunderstorm. Okay, it's cloudy, but there's also a thunderstorm. Now, we haven't gone over what that means, but I'll briefly go over it in a second here. And let's see, are we forgetting anything else? How about the pressure? How about the pressure? How about it's falling? In the past hour, it fell 9 millibars. And the pressure is currently, let's go 999 millibars. Okay, so a pretty good low pressure system with some serious kick to it and some thunderstorms that are occurring right behind that cold front. So let's draw out Bob's weather station here. We're going to start off with the station identification. Obviously, Bob's not a city, but we'll just say Bob's backyard station. So BBS. We'll just abbreviate it, okay? You can do this with your own weather station. So we're going to start off with our sky conditions. That's number 1. It's cloudy. So we're going to draw a circle. Okay, we always start off that circle. And because it's cloudy, we're going to fill it all the way in. Just boom, like that. Beautiful, nice and beautiful. Okay, just paint it how you want, your own weather world here. So We got cloudy conditions. The next one is our temperature. That is 59 degrees. So we're going to put it up in the upper left hand corner of this circle here. So it's 59. Okay, don't need the degrees. You can keep it simple. Okay, then our dew point is 36. We'll put that, remember, right below the temperature. But I want to show you something real quick. We're going to put it a little bit farther below. We're going to leave a little gap in between. Actually, that's probably not even enough. Go back one more time. This thunderstorms thing right here, we can actually plot those on stations as well. And I've attached a cheat sheet for special weather conditions that can occur, like fog, thunderstorms, snow. I'm not going to go over all of them. Okay, definitely not going to go over all of them here, but we're just going to go over thunderstorms real fast. The thunderstorm symbol looks like this. You're going to put this right in between the temperatures. Okay, it looks like that with a little arrow at the bottom. And if it's raining, you'll put a little dot above it, okay? If it's pouring, raining, whatever, you're just going to put a little dot above that. And it goes in between the temperature and the dew point, okay, like that. So that's where your special weather conditions are going to go. Again, I've attached a cheat sheet. We're not going to go over them all here. We're just going to go over that quick example. So we got that checked off. Now we've got our dew point checked off as well. Let's do our pressure next. We'll skip the wind. We'll do that last. We got a 999 millibar low, okay? Or a pressure system. Notice there's no decimal this time. So what do? Well, we cross off the 9 because we want to get rid of that 9. Remember, we want to get rid of that first 9, or if it's 1,000, we want to get rid of that 10. But we want 3 numbers still, remember? So what you can do is you can put 9, 9, and imagine putting a 0 there, because a 0 actually exists there. Imagine that 0 being there. So we'll take off that decimal, and we're left with 990. Okay, so that's how you convert that. So you'll put a 990 out here, okay, in the upper right-hand corner. So we got our pressure plotted. Now, our pressure is falling by negative 9 millibars. It's going down 9 millibars. So we'll put a minus 9 here underneath that, okay? So there you go. And now all we have left is our winds. So we got that done. We got that done. All we have left here is our winds. They're out of the north at 60 knots. So we'll draw our compass. Remember, north, south, east, west. Remember, these things point. Okay, well, I'm going to write this out just so we have some clarification. The winds are coming from the north at 60 miles per hour from the polar regions. Remember, with our little sticks, we put them out of this station plot towards the direction the winds are coming from. So the sticks would actually come out just like this. Okay, it's going due north. Since the winds are due north, it's going to come out, it's going to point towards the north. Okay, so that's step 1. Now, we got 60 miles per hour here. So remember our little key. The flags, those can cover 50 miles per hour. The sticks can cover 10 miles per hour. The long sticks, excuse me. And the short sticks, 5 miles per hour. So we'll just add these things together. We got 60 miles per hour, so we can get a 51, so we can check that off. And remember, these things point clockwise. Okay, they go in a clockwise direction. So the flag is going to point as if it was going around the clock in a clockwise direction. So we got that. And then we still got 10 left over, so because we got 60 miles per hour. So 50 plus 10, hey, that's 60 miles per hour. So all we need is one of those big ticks right there. And there you go. There is Bob's backyard station plot. It's cloudy, 59 degrees, dew point's 36. Winds are out of the north at 60 knots. There's a thunderstorm. The pressure is 900 millibars, and the pressure's falling by 9 millibars. So that is what's happening in good old Bob's backyard. So we have done our first station plot. Now we're going to go over a live example. We're just going to go over one on the SPC page that we looked at at the beginning of this video. So let's crack into it. All right, so we've arrived to the good old SPC page, and I've actually turned off the radar to make this a little bit easier to see. We're just going to quickly brush over some station plots. So let's go over to Pierre, South Dakota. This is actually at a different time. But here it is right here. We got our station identification, PIR, capitalized. That's Pierre, South Dakota. We got our temperature over here, 67. What's our dew point? Well, it's 61. It's down here. It's below the temperature. Not much of weather's happening, so there's no symbol in between. Our circle is not filled in, so it's clear. Our wind direction is pointing to the southeast. See that? So it must be from the southeast. The wind must be coming from the southeast. And to me, it's kind of hard to tell, but that looks like a long tick. So that's probably one long tick right there. And so that's probably out of the southeast at 10 miles per hour. Yeah, that'd be a long tick. See, this would be a little short tick. It's just like a little nub. That would mean 5 miles per hour. So there you go. And then our pressure would be 1,005 millibars. Now, the SPC doesn't necessarily do it the way we did it in that tutorial. They just kind of round their pressure. So if they had like 1,005.4, they just round it to 1,005. Okay, so sometimes that's one way to do it. The other way would do more of the formal way that I taught in the tutorial. Either way is fine, but just make sure you know what you're doing on that. So let's do one more example, and then we will wrap this tutorial up. Let's go out to our. Let's see. Let's find a good one here. Let's do Beatrice, Nebraska, down here. It's 73 out here for the temperature. The dew point 65. You got our station identification, BIE, capitalized. There's no pressure here. Sometimes there's no pressure readings. Either an error or they just don't have it. You know, sometimes they won't record the pressure. But there's no pressure reading out there. And then our little circle looks to be, yeah, man, it's hard to tell. I think that's half filled in. I think there's better plots out there than the SPC, but this is what we're using for now. It looks like it's half filled in, so it's maybe partly cloudy down there. And then you got winds pointing to the southeast at 10 knots as well on that one. How about it here? Well, it's out here. There's nothing filled in, so it's clear. 61 for temp, 54 for dew. Got your A&W, Ainsworth, Nebraska station plot. There's no wind, so it's calm. The wind is calm out there. There's no stick coming out at all. And there's no pressures on that as well, or any special weather conditions. Let's see if we can find any special weather conditions anywhere. Not really anything going on. No rain or anything going on. I don't know if the SPC actually plots those. I think UCAR does, but oh yeah, here we go. Right here. See that? Those 3 little dots represent rain. I'll take that off again. It's raining out in northern Wyoming, whatever station that is. So I've attached a cheat sheet below that has all of these little variables, and it also shows you the wind and the temperature and kind of a blank station plot that you can fill out and kind of use for practice. Okay, so that's attached below. So I hope you liked today's tutorial. And if you want to further your weather forecasting skills and learn more about weather and receive weather forecasting updates, go ahead and subscribe wherever the subscribe button is. I think it's right in this area. Go ahead and subscribe wherever that button is. Sign up to the newsletter, and I'll see you soon.